Listen. My fortune.
What do we have, Captain?
We have land, Mr. Murray.
Hello, everyone, and welcome back to Inside Unreal, a show where we learn, explore, and celebrate everything Unreal. I'm your host, Dan Hutnick, and I am joined by a few folks from both ARM and Sumo Digital who have come to talk with us about their newly announced project, Neural Dawn, and how they made MegaLights on mobile possible for this project. I, for one, am fascinated by this and can't wait to jump in. So with that, let's just do that. Let's jump in. Let's introduce our wonderful guest for today, starting with Lukasz. How you doing?
Hey, Dan, thank you so much for inviting us to this session. My name is Lukáš Medek. I'm art director at Sumo Digital, and also I'm a game director of the Neural Dawn project game. And yeah, I have more than 20 years in games industry with all its ups and downs. And I've worked on a bunch of games. My last published game I worked on as an art director it was the Starship Trooper, the Ultimate Bug War, the new boomer shooter from the creators of Bolt Gun. Yeah, I spent a big chunk of time working for indie studios. Sometimes I was the only artist working on the whole visual side of the game. So I'm basically used to create everything. But now, fortunately, I have a team of great people working with me, both in Sumo and in ARM. And yeah, I'm really happy to work on this new project that we'll be showing today.
Yeah, I'm super excited for this. Next up, we have Daniel. How you doing?
Hello, I'm Daniel Slaney. I'm an Associate Technical Director here at Sumo. I've been working here just shy of 10 years and in the industry since 1998, so I'm not going to do the math. I think it's a bit too long. Too many games to mention over the years, mostly working on the non-engine side of the graphics on this project.
Awesome. And next, we have Alexander.
Hello, Alexander Veselov from ARM. Started in ARM about 7 years ago, first as driver engineer for Vulkan driver, and then moved to what's used to called game graphics team, where we engage different partners, including Epic, and help establish collaboration on how to optimize engines. And nowadays, little bit of everything, but still mostly Unreal and optimization, low-level stuff.
Awesome. And last, but certainly not least, Sergio. How you doing, Sergio?
Hey everyone, Sergio Lapont here. I'm a principal engineer here at ARM, and joined ARM almost 7 years ago as well. So I've been mostly working on game engine tech, graphics, and in recent times, mostly in neural graphics and the collection of neural techniques that we've been developing. And before that, I used to work for Sumo as well. So back in the day, part of the industry as well in the game engine team. Yeah, so really happy to be here as well.
Awesome. We are so happy to have you folks here. This is a particular fascination for mine because I'm secretly, even though I'm not as much of an engineer or a programmer as I ought to be, I just find optimization fascinating. And I can only imagine what the process for that was on this. So I cannot wait to dive in. And we have a lot to talk about today. So we are not going to dally about too much. But I did want to say real quick, if you have any questions for the team here from either Sumo Digital or ARM, specifically about Neural Dawn and MegaLights on mobile, please leave those in the comments or in the chat, please, with question in brackets, followed by your question, and we will gather as many of those as we can throughout the show, and we'll toss as many of those to these folks towards the end as we can. Please keep these questions related to the topic at hand. If you have any other general ecosystem questions, Unreal, UEFN, anything like that, please head over to the EDC, the Epic Developer Community, where we have our forums, documentations, and plenty of other awesome resources. With that, I gotta ask, Neural Dawn, ARM, Sumo, MegaLights on mobile, how does this all come together? What was the start of this project? How did it change? How did we get here? What was the goal? There's a million questions here. Break it down for me.
All right. So I will start probably, and to just start with the bigger picture and put things into the context. Like 13 years ago, I was working on my first mobile game, and it was about vampires that needs to avoid light traps and basically to get to their cribs before the dawn. And the game was not about, it was all about basically avoiding lighting, but not only like in the gameplay, but also in the setup, in the levels, because me and my team were just not able to use that many lights as possible, and we had to use various hacks like light map baking and stuff like that. And even though it was a very long time ago, I can still see that the people, the developers, are struggling with the same issues even today, and look for the workaround. So that's why it's so amazing to work on the project like Neural Dawn that opens the whole new space of possibilities, and it's a huge technical leap forward. So if you can then show the presentation on my screen, I will just go through some initial slides.
Yeah, let's do it.
Thank you very much. So what we'll be talking about today, those are all amazing terms, and we will be talking about ray tracing, we will be talking about MegaLights, neurographics, or actor sequences, and it all runs on mobile now in our project, which is really cool, and it's a huge step forward. So with that said, we can use fully dynamic lighting in the mobile game with ray tracing on, with ray traced shadows on, to be more specific. We can use the power of neurographics to bring more performance to the on the table, so we can afford having this kind of features, and we can speed up the process of development by using various new tools, or just the fact that we can use the fully dynamic lighting. So with that, we can find new ways of creative work with lighting, and we can leave the formal lighting restrictions behind. As I said, we don't have to rely on baked lighting or a heavy optimization of lights. So that's great. About the Neurodon, we were asked by ARM about a year and a half ago to basically create a game for the new tech. Not a technological demo, but a full-scale game. And the reason was that people from ARM, they want to get a real feedback from developers. So the goal was not just to create a technological demo, like one room with beautiful lighting and ray tracing, or one short level and pre-scripted, but a full-scale game that will provide this feedback from developers to ARM as developers of those new technologies. And I think it went, and it still is an ongoing process, and it's really cool because we can see the tech, we can use it, and we can provide an immediate feedback to the developers of those amazing plugins that we will be talking about a little bit later. And a small side note, we at Sumo Digital are a small team that's working on the Neurodon. We are just about 17 people, so it's not a huge bunch of people, but the team is really small. But still, I think we can achieve nice results and to keep this a high level of visual quality and fidelity in our game. So that being said, let's start showing some stuff. So Dan, can I ask you to show the trailer for the game that we've basically announced yesterday? So it's pretty new.
Yes, let's jump into it. Amazing.
Thank you so much. So what is Neurodon about? just a very short description of the game. It's a third-person adventure game for mobile, where the players get into a role of an android that wakes up after deep sleep and then starts to explore a huge cave complex, learns about their past, and tries to finish the research. And the main goal of the game is interaction with the environment, and the main character uses drones. We call them bees, and it's possible to send them to interact with different interactive points or active elements in levels. And the game uses semi-realistic assets and stylized lighting, and the lighting is a core visual element of the game. So basically, the goal is to bind almost every interaction with some lighting change. The game is still in development, but the schedule for the game is pretty tight. We started last year, and the total amount of time is 18 months from the pre-production to delivery. So basically, very short development span. I would like to talk about art pillars for a brief moment. So the first art pillar, lights mean interactivity. It's about that we try to bind all those interactions with lighting changes to kind of prove or showcase the MegaLights in the best way possible. Reveal the Hidden is about that the players usually start in very dark and then gloomy areas, but after interacting with the environment, the place is starting to lit up and revealing various secrets and the new ways where to go. And the third art pillar, environment, is the star. Is pretty straightforward. The main focus of the game is on the environment, on the lighting, not that much on characters or cutscenes. So that's about the game, and let's talk about the lighting, which is basically the main focus of today's session. So we were able to enable MegaLights on mobile, and we can run it, and we can use it in Neural, and we can use all the features that it provides. So I will talk briefly about or give you a very, very short overview of MegaLights from my perspective as an artist, and then I will hand over to Alexander to talk more about the implementation on mobile. So MegaLights was introduced in Unreal 5.5, and it basically allows a huge number of movable lights with very low performance impact. When the MegaLights are turned on, there is this kind of like performance impact in the beginning, but the good thing is that with each added light to the scene, there is almost none performance raise, or the demand for the performance is not raising. MegaLights are tightly bound to ray traced shadows, so we are also able to run or turn on ray traced shadows on mobile. And what is great that we are not bound to this classic set of cheaper lights like point lights, spotlights, but we can also use more performance heavy lights like rectangle lights with soft shadows. So that's from me, and I will hand over to Alexander and then Sergio, because we won't be able to bring the MegaLights if we are not able to enable the tech from ARM, which is new upscaler and denoiser and frame generator. So yeah, the stage is yours. Thank you.
Sergio, do you want to start with denoiser, or should I start with ray tracing?
Can you hear us, Sergio?
Yep.
Uh,
Are you taking the lead, Alex, or? to start just talking about MegaLights and.
Well, okay, let me start. So with MegaLights on mobile, well, we already had experience with bringing up desktop-style render of Unreal to mobile. Right now, and still today, Vulkan SM5, which is closest thing that we can have to PC, is still marked as experimental. There are a few things that you probably will run to avoid, but overall, it's in a good shape, and otherwise, enabling it just works. With MegaLights, there was, I think, SM5 is not enough according to the engine. So we had to download the source and start to editing on the go. One thing that's specific here, on PC platform, in DirectX builds, MegaLights expect type load, which is a relatively new feature of DirectX. And therefore it asks SM6, something that current gen mobile doesn't support. But the feature itself is available from Vulkan 1.0. Any mobile phone that supports Vulkan technically runs everything what's needed. So we had to essentially find this very small little piece, comment it, add support, allow support for Vulkan SM5, and then it start to compile, let's call it. First runtimes was, as you can imagine, pretty horrible. We had black tiles, we had terrible performance, all sorts of things. Eventually, we find out that black tiles is because we hit scalability thing that instead of allowing any amount of lights per tile on PC, it strictly capped. And if you tilt angle of your camera just right to break this limit, it goes completely black. We didn't know ahead of time that this is a thing, so we thought we had a bug, and we spent some time investigating it. Once we've been at the stage when it runs, then we had a very hard and lengthy process of optimizing it. So we've been using ARM tools, which is part of our performance studio, which is available for everyone if you would like to repeat process. This is Streamline that shows GPU counters, what exactly GPU is doing on your mobile phone. We used RenderDoc, which allows to capture the frame and analyze how much GPU cycles every pass spends or how many arrays every pass traces, which is very important for this use case. Sergio expected that we will spend all the time optimizing MegaLights itself, but in the end, we sprinkle our efforts across the entire engine and grab everything we could here and there and everywhere. From things that I wrote down and probably would worth to mention, we change format flags for scene color and scene velocity. And this is very typical for any Unreal-based mobile game that you probably want to build with PC-style renderer. Unreal usually allows unordered access for both of those images, which is state-of-the-art on PC. And on top of it, MegaLights requires random access to scene color just to write its output from spatial denoising part. However, on mobile phone, it will disable or reduce your compression for render targets rate, which is not welcome. And something what we want to focus on is minimize memory write traffic. So compression for render targets is very important. So we had to remove storage bit and partially rewrite spatial denoiser from compute shader to fragment shader. Halfway broke denoiser in the process, but we knew that we will replace it with neural, and that ended up just fine. Other cool stuff that we changed is more aggressive render pass merge. For example, we know ahead of time that substrate is never going to be enabled in a game. There's no way. Virtual shadow map is not going to be enabled because it's ray trace based. So we can rely on it and allow merge to be more aggressive, such as fog and transparent render pass can be fused together. Once you fuse your render pass on mobile, that means when you're starting, GPU loads the tile in a local memory, which we call tile buffer. This memory is very fast, that battery efficient. It do 2 passes at once on this memory, and then there's only single write in the end, which is just better than doing one pass, write it down, and then read it back immediately. And we had the similar optimization for gbuffer clear plus base pass merging together. There are a few more optimizations that we done. Sergio, do you want to maybe step in and have a few words about later?
I guess from my side, I could go over a bit the story of why we decided to go for MegaLights, and which is kind of linked intrinsically with the idea of the project itself. Obviously, when Neural Down started, we didn't have the restrictions of having to run this game on devices that are 10 years old. We were targeting the devices coming later this year that come with our neural accelerator, because the key was to demonstrate really nice lighting and showcase our neural frame rate upsampling and NSSD, which is our combined upscaler and denoiser. So in the early days, basically, we were wondering what sort of ray traced approach we were going to use. We knew we wanted some sort of ray traced lighting. We weren't too sure how this was going to look like. And internally, we actually started experimenting with an optimized version of Raster DI, which is like the original ray traced stochastic algorithm that NVIDIA produced in 2020 or in 2021. We were ready to jump to Unreal and implement the whole thing. The funny thing is, it happened to be that we went to Unreal Fest at the time, exactly the same Unreal Fest when MegaLights was announced. And right on the spot, we just realized that, they're just landing something that happens to be exactly what we need for this project that we are just kicking off. So immediately, as soon as I came back to the UK, we triggered an early evaluation of the algorithm, which, as you can imagine, it was super experimental, kind of buggy as well at the time. We just started doing, bringing it down to Mali, running it, doing some performance analysis, and we actually realized that in terms of the noise patterns, it was much friendlier than the Raster algorithm that we had separately. So it was kind of friendlier as well for the architecture of our denoiser. And yeah, it was more expensive than that optimized Raster DI, but on the other side, it was already there in Unreal, and it was already super well connected with the material system and with all the lighting system in the engine. So just by using MegaLights, it was going to save us an insane amount of work. And we could actually benefit from all the work that folks from Epic are doing on the sidelines, improving the algorithm. So anything in particular you want to know, or do you want to keep on going for a bit, Alex?
I guess we can keep going with ray tracing. Like you said, yeah, when we see in MegaLights, it's just something that makes sense. However, we knew that ray tracing on mobile is in a reasonable shape for us, but it's not all capable. It's not your high-end PC GPU with constant power source. So we knew we would have to make some trade-offs. And one of the things that been expensive at the day, and when we started project, we only had only Gen 1 devices for testing. And one particular thing that they struggle is alpha test geometry, because it interrupts your traversal cycle, and then you go back to shading, and then go back to traversal, and you can bump in and out multiple amount of times. MegaLights addresses this problem for PC in PC manner. So they have one main ray and then continuation ray, something what you mentioned in SIGGRAPH presentation. However, on our device, the challenge was that difference mainly comes from the decision that compiler makes. And that means shader compilation needs to know ahead of time what you're gonna trace. And that wasn't quite realistic in game overall. Because if you just build your traversal algorithm and you don't assume anything from game, then how you know at compilation time what's going to happen? So we ask Sumo to take this into account. That's why instead of bushes, forest, you see mushrooms. And now that allows us to put force opacity flag, essentially inform a traversal algorithm. Hey, do not expect any transparency. And from there, it helped to optimize register pressure. It helped to utilize GPU much better, and ray tracing just became significantly faster just from this flag alone. Something what we also had to do for this in MegaLights, there is support for I forgot how you call it in the engine, semi-translucency material, and this also technically transparent for ray tracing unit. And Unreal had uniform to control it. However, uniform to shader compiler is essentially some input that comes from the game. Has no clue what it's going to be. So we had to rework this part, and instead of having uniform that goes into shader, create shader variants. And then we run into shader compilation limit and just increase it. Once it was said and done, it was already in reasonable state. Even on first-gen devices, we wished to test it earlier on second-gen, but it was only in silicon. Sorry, only on FPGA, nothing in silicon, so it wasn't available. But it was good enough to test on RTV1. Something else what we then changed in MegaLight is how they control tile coherency. Something what you do in the engine is to calculate hash of a list of locally available light sources on a tile, and that helps engine to reason about, are we seeing same set of lights for this region of pixels on a new frame? Can I leverage information for previous frame for my temporal denoiser? And if this hash doesn't match, it throws tile away and starts from scratch with slightly bigger array count. And that helps with coherency. This hash table is a giant buffer, what was a little bit unfriendly for mobile phone. Just clearing it alone took about half the cycles that takes to fill G buffer. And we had to completely redesign this algorithm to write immediately ready to go data from the tile and potentially do more work in tile analysis. However, on mobile, it's completely fine since device is specifically disproportional. Memory is very slow, but arithmetic relatively to how much memory can deliver to you is very high. So it was good optimization. We get about 20 million cycles back, and yeah, it worked for us. That's probably key points that I was planning to mention about optimizations. I also have a note about SDF. However, I would assume Daniel would like to step in before we start to talk about distant fields.
So we answer some of the questions in the chat before they start accumulating.
Question.
And
yes.
yeah.
Yes, absolutely. Sorry about that. Put that in the chat right now. There we go. Perfect.
Yes. Right, yeah. So someone was asking about pipeline document or anything that can be shared or showcased for future devs using ARM. I'm guessing you mean Mali GPUs. I mean, we have the developer.arm.com portal with full of documentation, tutorials, guides, and all sorts of materials. So the document that we just shared in the chat is like the latest landing page that we prepared for kind of a landing page for the work we've done with Neural Down. But yeah, through there, you can access everything else, basically. The second question seems to be only neural rendering processors can access this on mobile, right? Because there are devices out there with the neural accelerator right now. Yes, you need these coming devices if you want to run our neural use cases, but when it comes to just MegaLights, you can just run it on existing devices, really. So long as you have hardware acceleration for ray tracing, so it doesn't run too slow. As a matter of fact, we test on a daily basis with production devices, I think, and I think Lucas will probably show it running on a device later on.
Yeah, absolutely. Like the problem with that, we can run it on the current devices, but the demand for the performance is so high that the phone gets warm really fast, and it's really eating a lot of the battery. So that's why I think the goal is to bring this neural accelerators to kind of like keep the performance demands of the device low, so you can basically play it for the long time and don't spend the battery in a very short time.
Yeah. By the way, I just took the lead at reading these questions, so that be my guest if you want to step in. The next question is, can you talk a bit about PC projects that might want to be available on mobile, but don't have the resources for a full art redirection or redesign to make it performance acceptable? Well, any advice as the artist here, Lucas?
Oh my God, that's a tough one. Oh, I don't know. Sorry, my head is empty. Right now.
Okay. If not, I guess I could make some comments myself. So in part of the work that we do in my team and Alex's team is to look at the future and how future graphics on mobile are going to be, or future content running on Mali is going to be. So we keep thinking about these kind of console-like and PC-like titles moving to mobile in the future, and titles that might get ported and we've seen already plenty of examples that are being cooked in the industry. In terms of advice, I would say, well, usually, try to have some scalability settings in your engine. That definitely works. Go for lower quality mid-maps for your textures. Go for lower resolution, maybe. I think these days using an upscaler is definitely a kind of a standard, and it will definitely help you a lot when moving to mobile. So I would say go easy on it initially. Try not to drop too much on the way, and baby steps, keep on profiling along the way. But yeah, I wouldn't go, I don't know, maybe you guys, Daniel, Lucas, have a different view, but I wouldn't go and do a whole remake of the game for mobile. But it all depends on what your target devices are, right? If you run on the recent generations of devices, these are super powerful. If you want to go for more aggressive older devices, then you might need to make some quality sacrifices there.
Yeah, I think it's not just about optimizations. It's also about, and we are struggling with this issue all the time. It's about basically the readability on the small screen, because like if you play the game on a big screen that is covering like most of your view, you can spot so many details, and you can basically read the the level, the compositions, whatever, much better than on the small device. And especially if you bring like the some kind of like detailed game with a lot of assets, with a lot of kind of like noise, visual noise into the small screen, it starts to be really tough to read it, to navigate in it, and basically players are struggling with playing the game, and this can be a more kind of like game perspective related problem. And as I said, like being able to run all those cool tech on mobile is really challenging, because you want to add so much stuff, and then you play it on phone and you end up with, where should I go? Where am I at the moment? And you need to kind of like scale the amount of detail down to find this kind of balance between this amazing visual stuff and the actual kind of like game and the navigation and readability of the levels and space.
And that's an interesting point to like kind of emphasize, right? Which is the difference between like having the ability to do something and whether it's necessary or whether it's beneficial in this case. And I imagine it was probably quite liberating to be able to just, throw all these lights everywhere, like this is so cool. But then, like you said, once you start playtesting, you go like, oh, actually, now it's not as readable. Now there's issues with directions or guiding the player or anything like that. Like those are things you might not consider initially, but then come up as you start, developing and playtesting and all that stuff.
Yeah, it's our everyday struggle right now to find a balance, and showcase the dynamic lighting.
But one of the things is that previous to this project, it would be incredibly common that if you were doing a larger AA, AAA, quadruple A game, the mobile version would be considered an entirely separate project. And the content would have to be recreated or made again almost entirely from scratch, even if you had the similar source materials. So it would cost the same as a normal project. Now, with some of these technologies coming to mobile, that is not so clear cut. If you were starting a project now that might be finishing in 3-4 years, being able to use your main game assets, obviously you would still like polyshop them down or use lower LODs or something, but the technologies on mobile are appearing now that makes that viable where it just wasn't viable before.
Yeah, exactly.
Maybe I can add a little bit software point of view to this. Do not expect mobile to be a desktop GPU, just smaller and slower. It's different. It has its own disproportions. It might be surprisingly fast when it comes to number grading, because numbers are easy. We kind of know how to do numbers. And in the same time, like I said before, it's very slow, especially when you need to write output. That's why MegaLights significantly better than previous ray trace shadows available. If you turn it off and go back to previous ray tracing in Unreal, you will run one ray tracing pass, store it into image with a little bit of blue noise. Then it will run denoiser, and what oftentimes happens, even on today's mobile phone, the denoiser is more expensive than actual ray tracing. And MegaLight is better because it has only 2 denoising paths in the very end. One for your diffuse low, one for specular, and then it's done.
Yeah, exactly. We are no longer in a world where you just have your forward pass and then some post-processing and call it a day, right? Nowadays, the frame structures are super complicated, and the rendering the scene is but a tiny fraction of the frame at the end of the day. So, kind of referencing back the question about the content, the content itself, unless we are talking about billions of triangles, of course, and you are super geometry bound, it's not as important as in making sure that you are rendering the frame efficiently and that you have the right budgets in place. And this kind of links really well to MegaLights and why we decided to go for MegaLights in our case. So for us, and NSSD in particular. So NSSD is screen space, temporal, neural, denoiser, and upsampler. So, and this means that in a similar way to how DLSS solves it, we apply the work after applying the lighting, after particles, after translucency, and we just upsample to our target resolution and resolve the noise, the denoising in one go. Now, this means that that first section of the frame needs to have the right bottlenecks. And one of the really common questions that I've been answering hundreds of times already for the last couple of years is, does my content benefit from an upscaler? And I'm sorry, but the answer usually is like, well, it's not as simple, right? It depends on where your bottlenecks are, how complicated your lighting is. Are you fragment bound? Are you compute bound? Is the frame budget before upscaling scaling based on resolution? Or so you need to do the profiling. You need to run the maths and profile at the end of the day. Evaluate these budgets. And going back to the point of MegaLights, the good thing about MegaLights is that your bottlenecks and the complexity of the technique now scales with resolution, which means that when we start reducing that source resolution in our frame and the domain of MegaLights, we can improve the performance and the bandwidth of the frame drastically. And then we just plug NSSD, upsample, and denoise in one go. So the whole frame becomes way cheaper. Because we are making sure that the frame makes everything else shine here, and the right bottlenecks and the right complexity of the problem is in place.
Yeah, I think that it would be really interesting if Daniel can show or Dan actually show this kind of like analysis of the power or performance consumption in Neural Dawn, and we can see like what is the structure of it.
So to explain what the context of this is, we run nightly tests on recorded gameplay footage. It's like a sequence of plays through a level that's been recorded and can be played back so we can have reliable performance numbers. We use the CSV profiler in Unreal, and then there's a perf report tool built in Unreal, so you can build some lovely graphs, and this is one of them. One of the main things to point out here is MegaLights is the solid blue section at the bottom there, which, as you can see, is about 45%, somewhere about that, of the performance of the frame. There are other passes as well that are technically part of MegaLights, but that's the main one. The reason that we do these kind of tests is obviously so that we can track, and we want to get proportional, but even though it sounds like a lot, it's worth remembering that this is the shadowing mixed together with the lighting. So normally, if you're looking at one of these kind of frames from deferred rendered games, you're used to shadowing to be being a reasonable proportion. You're used to the G buffer or the base pass in Unreal terms being a reasonable proportion. You're used to lighting being a large portion, then post processing being a large portion. And two of the portions there are just taken up by MegaLights. The base pass is very, very rarely is a couple of milliseconds on this particular kind of test, because we're going for 540 and then upscaling up. So the base pass is really rapid. We've actually, because of CSV profiler giving so many data points on a large graph, we've actually tested the correlation of every single possible stat that's been put out by the CSV profiler. And the strongest correlation with MegaLights, general GPU performance, has been number of primitives, which kind of makes sense because when you're ray tracing, the more polys that it's ray tracing through, that's going to be proportionate. But the number of lights has never turned up as being proportionate, apart from the one pass that is, I think it's the composition light pass, which is the least expensive pass is really there. So this is the kind of graph that we're looking at daily, and if it's not there or not right, or sometimes there's big spikes because it's taking a screenshot of it going too slow. But yeah, this is the kind of stuff you can use with normal Unreal tools now, whether you're MegaLights or not, but we would highly recommend using this.
And I would argue that while that is a large, percentage of it, compared to everything else, it's also doing a large amount of the work, right? So like it's very heavy lifting in terms of not only what's available visually, but also then what you can do mechanically, because it seems like lighting is a pretty big part of the mechanics design as well. So
Well, it's not just the lighting as well, it's the shadows. The quality of shadows that you will get from MegaLights, if you were trying to compare it through other means, would take up probably, as a percentage-wise of a frame, more than this. I'm frequently surprised on mobile or in running this on a PC, the quality of the shadows especially.
So there are a couple of questions. First one is, what might be a decent low-end device to develop for regarding this? I don't think I'm in a position to point you to a particular device, but I would say that any device with our Immortalis G715 GPU, which is used in MediaTek's SoC, I would say any device with that has the capabilities to start running MegaLights in a reasonable budget. And I've been testing on a device that is a couple of generations old now, and it's running at, I've seen it running at over 50 FPS. For how long? Well, that's a different story, but
Yeah, if you play it in the freezer, like you can play like for hours,
exactly.
basically.
Yeah.
It's
tablets as well run cooler, don't they? There's like tablets are naturally cooler than phones because they've got large backs and they can dissipate heat.
But for one last point, and I'll move to the next question. This time for Neural Down, we are doing things differently. We are targeting these devices coming later in the year, and we are actually not looking for big performance. We are actually aiming to run at stable 60 at a fairly sustained performance. So you can run at 60 FPS with MegaLights for, I don't know, hours at a time, hopefully. And the last question is it's a really interesting one. MegaLights looks like an extremely high cost. Is it really worth it compared to baseline Lumen without MegaLights? What are your stepping back insights on what features are hardest for mobile? Anyone has any observations? And if not, I'll keep on going myself.
They're not
I
directly.
can maybe. Sorry.
I was just going to say, MegaLights and Lumen are not necessarily directly comparable. We're not using Lumen in this, but they do achieve slightly different things from a game dev and an art point of view. Sorry, Alexander.
Yeah, I was about to say similar thing. It's a different tools. MegaLights address your direct lighting, and it's more replacement to shadow map, something what we can discuss. And Lumen addresses global illumination. When we started work on Neural Dawn, we had assumption that it's unlikely that we can support both at the same time. We didn't know just yet that in the future, in 5.8, there will be a medium lumen preset, which is mobile friendly. We didn't know that, unfortunately. And in terms of what delivers more, it will depend a lot on the game. This game is specifically designed to deliver with direct lighting. So there is a lot of small things that illuminate the level. If your game is, I don't know, maybe some cave with open ceiling where light pierces in a beam and reflected all around, then maybe Lumen is right tool for you as well. In terms of what is expensive on mobile, as usual, in Lumen, tracing rays cost something. Denoising costs more. That's a usual challenge with mobile.
Yeah, well said. I guess that's the key. These are different techniques for different kind of lighting. One focuses on the direct illumination and the other one for GI. In terms of budgets, well, we've made high-end demos in the past, like one every year or so, and we have plenty of demos now showcasing Lumen running on devices as well. My take is that both techniques were designed and have been implemented with console and 4K workflows, or to target all these high-end platforms, definitely not mobile. And in my experience, MegaLights turned out to be friendlier for mobiles compared to Lumen. As in, I think you can use MegaLights on a production title today. While I don't think I could say the same for Lumen. Not if you want to maintain the performance.
Yeah, exactly. Like from my perspective, we basically use or we are using MegaLights to fake global illumination because we can afford having so many lights in the levels that we can basically place the lights all around, and we are using lights with very low intensity and large attenuations to basically mimic the GI with a lot of colored lights scattered around the levels. Because we've tried a multiple of G solutions, but there were either like errors like light leaking or shadow leaking, or the performance was really demanding. So we basically end up with faking the GI with many lights scattered across the level, which is great for small to middle-sized game because you have a huge artistic control over the result, and you can really like play with the different lights and basically you can paint with the lighting, which is amazing. I wouldn't definitely recommend it for open world game because it will be insane. But for this kind of like smaller project in a size of levels, it's really like pleasure to work in that way. So
Lighting
yeah.
artists would love this. In general, lighting artists would love the level of control, and the fact that you can use area lights and multiple, and you can sit there going, look at the number of lights and go, oh, it's hundreds, and I can't even tell, and half of them are area lights or something like that. Is very impressive.
I thought the artist loved. Sorry, look. I thought the artist loved spending hours optimizing the lighting, right?
Yeah.
Yeah.
That's the fun part. Thing. Placing the lights is boring, but optimizing them is super fun.
Yeah, actually, like with MegaLights, you don't have to, almost. We even tried to turn off the shadows for all lights in the game, and it didn't make almost any impact on performance, actually, which is surprising, but yeah. So yeah, I have few examples prepared, like live examples in the editor. So we will get to them after a few topics that we have in our list. So just the wrap up from the again artist perspective. So how we are using MegaLights in Neurodon. So all lights in the game are dynamic, and we can render hundreds and hundreds of lights in one frame. And to be more specific, we are like in a range between 800 lights to 1400 lights that are all dynamic or are casting shadows, and there is almost no kind of like this distance optimizations set up in the levels, and it's still it runs on the phone, which is amazing. And with MegaLights, we can also avoid this kind of like problems with the speed of the development that are relying on the baked lighting with all its errors and time-consuming stuff like setting up light maps, correct resolutions, a lot of lighting errors, and especially like very long waiting times for bakes. Then checking if everything is correct, adjusting the setting, and waiting for the bakes again. So what we see in the Unreal editor, we can get in the build, which is really amazing, and it really speeds up the process a lot. So yeah, I think we can move to ray trace shadows. We partially covered that topic, but still, I would like to say a few words about the visual side of ray trace shadows. So with them, we can really get or achieve the high qualities of shadows, which is amazing, and we can avoid all these kind of usual problems with cascade shadows, like gaps between the shadow caster and the shadow, or the necessity of dealing with the low quality shadows in the distance, or even removing the shadowing in the distance, because with ray traced shadows we can get nice and crisp shadows also in the vistas in the bigger distance from the camera. And what is amazing about ray traced shadows is that they are precise. And we can achieve this kind of very nice effect of sharp shadow near the shadow caster and more blurred shadow in the distance, like further from the shadow caster, which is basically like mimicking the real life shadowing. We have no shadow bleeding, and the noise produced by soft shadows is handled by NSSD, which is also great. With ray traced shadows, there are not only pros, that there are also cons. So I will hand over to Daniel again to talk about this kind of dark side of ray traced shadows, because it's in some aspects of the development it's limiting, and we have to follow a set of rules that basically forbids us from using various kind of industry standard approaches or features. So Daniel, over to you.
Cool. So these have been some of the more challenging, just because it means we have to readdress what the things that we've been used to doing for maybe 10, 15 years now. It might even be longer than that with my memory. So alpha cutout. So a common thing that might be alpha cutout is foliage. So if you have a hedge, commonly it'll be made with a quad per leaf, and then you'll have a texture that's a single bit alpha, maybe a bit more if you're trying to make fancy leaves. Due to the issues that Alexander was mentioning earlier, this is probably not the best fit for us. So you would want to make something like that from actual geometry, opaque geometry, as much as possible. With ray tracing, there's one of the bigger issues is acceleration structure construction. I don't know how many of the people watching will understand all about acceleration structures, but basically there's a top level acceleration structure, which is most of the models you'd normally think of as, and then there's the bottom level acceleration structure, which is your individual models being stitched together. And when ray tracing is being performed, so that it doesn't have to check every single triangle in the scene, it's using this tree of boxes, and it goes, oh, if I'm going through this box, let's look inside it. Is there a triangle? Or there's another box, go inside there. Eventually you find a triangle, and whether you like with that or not. However, those trees of boxes, the acceleration structure, anything that's animated for a skeletal mesh, a skinned mesh, or something that uses world position offset as well, which is very similar to using vertex shaders to move positions. What it means is that acceleration structure needs to be generated for that frame, for all those bits of geometry. And if you have a scene set up and you have lots of animated skeletal meshes moving around, you will very rapidly notice that in a profile. So we have to be fairly, what would I say? We have to be very careful with the amount of things that are being used, and there's a bunch of techniques that we can. I don't know if now's the right time to go through the techniques that we would normally do. It probably is, yeah. So we've got. So one of the things we do is we look at a skeletal mesh and we say, does this actually need a super accurate shadow? So does it need to actually be doing the MegaLights shadows with a mesh that's fully accurate to what's being used for the base pass? If not, then we can use either a lower LOD of that. We've also made a component with a skeletal mesh optimizer. Cool. We've got a skeletal mesh optimizer, and in that we've got a few settings that we want to set. That we want to enable. One is if you want to be able to make a manual shadow mesh to override a skeletal mesh, then you can put that in, and we just call that the shadow mesh. You can do that in Unreal yourself manually by adding another component, and you can say disable for the one that you want for your base pass. You can just say don't use ray trace shadows, and then you can have another one that you say don't render and do ray trace shadows. This just is a convenience tool for us. There is also settings that we have for if you're using lower LODs for ray tracing, that's a normal Unreal built-in facility. There is also, do you want to switch to a different static mesh as part of an animation blueprint? So if you're doing something that's animated, you might want different meshes to be played in different states or at different times. So we have the capability to set some things like that up. There's also, when we do change the shadow mesh effectively, what do we want to do that at a certain distance? Because the fact that it's a skeletal mesh still might potentially mean that there's some building of the acceleration structure going on. So just to make sure it doesn't, and then we have distances for when that will be enabled and when that will be disabled. It's important to make those two distances different, because otherwise our eyes are very, very good at picking discontinuities, and there's like a very specific distance when something slightly pops. You will pick that up really well. So what you want is to enable at one distance, then disable at another distance, and that'll cover that. I think that's a fairly, what would I say, making LODs and doing this as passes as part of the development process is a very, very common art pipeline thing. It's happened for a long time. So this tends to slot into that kind of part of the content making process, but it is something that we have to be wary of. There's also, we want to make limited use of transparent materials anyway. Part of that is a fill rate thing, and part of it is if you have too many transparent things that aren't casting shadows, it becomes a little bit uncanny. So you have to be a little bit careful of that from an artistic perspective as well as a performance perspective.
Yeah, we are using some transparent materials in the game, but we are usually turning off the ray tracing or ray trace shadows for them, so we don't have to deal with kind of like performance issues. Yeah, also there is a problem with the world position offset, right?
Oh yeah. So the world position offset, to reiterate that, is so what that forces is, even if you don't move a pixel or you don't move a vertex, sorry, when you're making a material, the engine doesn't know that, and it has to rebuild the acceleration structure for everything. So world position offset is something that we use incredibly sparingly, or we use it on things that are like emissive, and we stick lights on them, and we can stick loads and loads of lights on them. And if they're emissive and they glow, then it doesn't matter that they don't necessarily have shadows, because things that glow don't tend to have shadows in films, and we're easily, I would say, we're used to that not happening.
Yeah. Also, with the version of MegaLights that we are working with right now, we are basically restricted from using direction light, which can sound like a huge issue, because that's why we put the game in the like underground, into the cave. But if I remember correctly, like the MegaLights will be supporting a directional light in the future updates, or maybe they are already are. So yeah, that's a restriction for us, but not for the future projects, I hope.
Yeah, I don't know if we mentioned that we're on a version of 5.6. Obviously, there's got lots of optimizations and engine mods, but it's 5.6 currently.
Yeah, as far as I remember, beta version of MegaLights that came with 5.8 already has directional light support. So anyone who picks from today should be in a way better position. But back then, we had to work with experimental version, and because we forked the engine, what we call a vintage version of Unreal.
Yeah.
I don't know, is this also the point to mention some stuff about distance fields as well? So I believe there was very early on in the project, distance fields were taking quite some time to update. And because we don't need to rely on distance field shadows or anything else, the only thing that we'd really be using them for is AO or distance field AO. And I believe there were some optimizations made, and then we've ended up using, in this phase of the project, we've got a screen space bent normal implementation, so that we don't need the distance fields anymore. I can't remember the exact numbers. Alexander, can you remember the numbers that they were taking?
Yeah, for distant fields, update of SDF structure itself took about 20 million cycles, so it was more expensive than full ray tracing in MegaLights. And after doing all this work for updating distant fields in, it just ambient occlusion and then it's done. And I looked at it with, software point of view. That's unacceptable. We need to turn it off. And then I looked at the image. Yeah, it looks the same. I sent to Lucas, and Lucas responded, "That's completely unacceptable."
Yeah, the point is that you get all this kind of like wet, glowy surfaces all around the level, which is really destroying this kind of like nice lighting and stuff. So we basically had to come up with a solution that will helps us to fix that. And that's what the bent normals AO does.
We struggle a lot iterating this, as I remember. We, at some point, even considered to enable ray traced ambient occlusion, because how bad it can be, right?
Yeah.
Famous last words.
Yeah.
In the end, we stole bent normal shader from Lumen, and that was, I believe, final solution that we end up with.
All right. So, sorry, go on, Sergey.
A couple of questions in the chat. First one is, will MegaLights support older non-RTX GPUs in the near future? I don't think we can comment on this. Reach out to Epic. Is their roadmap, their engine? And the second one is the deferred pass with MegaLights always in compute shaders? Mobile GPUs can't compress frame buffers from compute shaders, and the next passes will also be forced to use uncompressed frame buffers. Any comments, anyone?
You can go first, Alexander.
Thank you. So that's a very nice question. So yes, it's gbuffer-based game. Is very common for Unreal-based games. What you can leverage once you render gbuffer, MegaLights only interested of reading it. It doesn't want to write new data, unless you have some non-trivial, non-MegaLight related effect on your gbuffer. And since it's only reading, not having storage bit is totally fine. Compute shader can read textures. There is no problem with that. And then what MegaLights want to have is write access to your scene color, because it wants to output your light. And this is why we rewrote spatial denoiser from compute shader to fragment. So what happens in MegaLight pipeline, it runs all the lights, then it runs temporal denoiser, which is compute shader, but we didn't manage to avoid. And then from compute shader, we just do temporal thing. Spatial shader picks storage image as a fragment shader, and it outputs render target image, and then we back to normal mobile-friendly flow. However, it was before we start working on neural denoiser. And maybe Sergio can give more context. From what I know, with neural denoiser, even these parts are gone completely.
Yeah, so it's a really good point. As you say, we have AFPC for render targets, and only fragment shaders support writing to AFPC compressed data. So one of the common tricks whenever we are optimizing anything on mobile is try to move as much work as possible to fragment shaders as opposed to compute shaders, because then you can get fancy compression in your output render targets, and At the end of the day, mobile is all about bandwidth and it's all about the power, and that's what is going to allow you to play for a longer period of time. So there are a lot of compute passes in MegaLights and in the frame when you run with the SM5 renderer or the desktop renderer on mobile. And we are definitely doing a lot of these kind of optimizations, even right now, trying to move things to fragment shaders when it makes sense and trying to get back some more bandwidth and improve the performance world. And as Alex said, one of the really early things that we did was to cannibalize a bit the MegaLights ad hoc denoiser to optimize things. And when it's disabled, we use it as some sort of composition stage. And we just now write a unified render target with all the lighting information for our denoiser. And in the case of NSSD, our denoiser, so it started as compute only, and over time we've been polishing it and optimizing it, and now most of the work that happens in NSSD is also fragment shaders.
And also from
the same goes for NFRU, which is the frame rate upsampling that comes later in the frame.
And from a higher level, we've not mentioned it previously, but it's also, you wouldn't use Nanite to do a G-buffer fill or anything like that either. So we're just using normal Unreal. So it says base pass. It looks very much like a normal deferred base pass.
Yep.
Yeah, I think that it's worth adding that basically we are approaching the asset creation as if we were creating a PC or mobile, not PC, not mobile, sorry, but just a PC or console game. So we can have basically millions of triangles in levels and quite big number of draw calls that we can afford and still run the game in the reasonable frame rate.
Yeah, we're doing multiple thousands of draw calls, and it's one of the huge advantages of Vulkan compared to loads of older things is that is not as proportionate as part of our cost as we would expect.
Yeah, absolutely. Okay, so I don't know, is there a good time to show some examples how we use the MegaLights in Neural Dawn? I have few slides that are more static, but I think maybe like right now it's the good time to just jump into the editor and show some few examples of how the setup is done. So I will just check that. Yes, you can see my screen. That's great. So this is a snapshot of one part of one of the levels, and you can see that like there's a lot of icons, a lot of bulbs, and like each of these lights is light that is dynamic, that has the shadow casting on, and can behave in a specific ways and can be basically triggered by players' actions. So let me just hit a play and showcase like this what we basically seen in the trailer, but in the game. So yeah, the game is third person, obviously, and kind of like multiple ways of how to turn on the lighting or change the lighting in the scenes. So one of it is just to run into stuff and activate it, and then we have options to basically gather these drones, those bees. That can accompany the player and that has their own lights. They are using a lot of light functions, and that can serve as basically as its own light sources. And I just go into the the blueprint of the bee. I hope that the game won't crash. That you can see that we have again like multiple lights on each of the bees, and we are also using, for example, the rectangular lights that are usually like pretty expensive because they are kind of, they have their rectangles, so the light is cast in a much more difficult way, and we can achieve the nice quality soft shadows. But we are using them just casually on the bees, on the drones that you can gather through the game. Also, other ways how to change the lighting is basically to interact with various objects. I'm sorry, there are some particle systems loading, but nevertheless, you can just send the bees to the specific points, and the interaction is done. Or we have this kind of like material that is changing based on the player's location, and that can be used for, again, changing the lighting of the scene. Is done by adding a lot of interactive lights. So basically, like the flowers or the plants that are glowing are disconnected from the lighting; they're just emissive. But we have a lot of lights that are placed in the space and that are triggered by the player. Or we have this kind of collectible stuff that triggers the cutscene, and you can see how all those plans are activated. We built our own tools for previewing the lighting change, because there are a lot of objects that are that are not static regarding the lighting, but they can change. So we can just push one button and see how the lighting is changing upon various interactions. And also we've managed to create a custom tool that is called Light Animator, and this tool basically allows us to switch between two states that we call sleep and awake state, and we just set the gradients or colors that can change in time. So basically, not just colors, but also the intensity that is controlled via the opacity curve. And we can set how the light is behaving regarding the intensity, volumetric scattering, or attenuations, and how it behaves in the sleep state, and also when the object is interacted with. And then we just take the lights that should be affected by the light animator. And we say, okay, this is animated, and the light animator automatically assigns all those lights and set the parameters that are set in the component. So this is basically how we can achieve this kind of like constant change of lighting, because again, like I would try to repeat that the goal of this whole project was to show the power of MegaLights, and if we just set all the lights to be kind of like static and having like a lot of lights in the scene, it wouldn't be that obvious that the lighting is dynamic, because you can achieve it by via light maps or light map baking. So yeah, this is one example how we can trigger lighting, and as I said, we are also using a lot of lights with pretty big attenuations. that can fake the global illuminations. So what is great with MegaLights is that, for example, if I'm setting up the light, changing the parameters. Why it's not on? Let me just put a new light here, because that one is probably bind to something. And let's pump up the. Okay, actually, let me just create a fake GE light. So right now, like let's say this is our fake GE light that we are using for basically coloring the environment. But the problem is that the shadowing here is pretty heavy, and you can see this kind of like border of the shadow, and the shadow is pretty sharp, which is not really something that we want to see from the light that should be just faking this kind of like soft lighting. Oh, sorry, I'm not showing the details. The thing how we are dealing with it, and as we can afford having the shadow casting on, we can just raise the source radius, and you can see that if you do it, you can get this very nice soft shadows around objects. Because one option is definitely to remove the shadow completely, but you can get this kind of like very weird looking normal maps that are light up by the light traversing through the assets, and it doesn't look that great. But if you turn on the shadow and just raise the source radius, you can get this kind of very nice soft shadow, and still be able to basically work with the high attenuations and low intensities to kind of mimic the GI. So this is one of the solutions that we are using for Project Bus. I forgot, I think, to show how we are dealing with the number of lights.
Yeah, we had a question in chat where they're like, how many lights with like 3 question marks? They are very curious.
Okay,
and so am I, because it's amazing.
Okay, so let me just run the stat rendering, and we have. Oh, this isn't the right number. I think it shows the right number in when the game is not. Yeah, this is number of lights in the scene. So we are dealing with or we are having 1,433 lights currently in this level. So it's a huge number.
That's actually in that should actually be in that scene. If you can turn around and lights become unneeded, that number will change.
Yes, absolutely. So just to make a proof, we have just to show how the level is big. So as I talked about the size of the levels, this is basically the average size of our level. So it's not that big, but you can spend a lot of time in it. And we can afford like having this kind of very granular lighting, and we can afford like spending time on each location, because there aren't that many. So if I sorry, that console, show the stat rendering and just interact with this thing. And we are turning a lot of lights, so you can see how the number of lights is increasing. So that's basically like how like the Unreal is dealing with the number of lights in the game. And one amazing tool that we have is, as we are turning on a lot of lights in sequences, we've built the tool that allows us basically to pick lights or lighting objects that are activated. So we call the component state switcher, and it's really convenient to use because you just click on the button, pick activatable actors, yeah, and you can just pick any interactive object that don't necessarily need to be light, but in majority of cases it is something containing light. And you can just pick a number of assets, and you can just set the time in the sequence, or you can change it to be turned on by the distance. So basically, the activatable object or this kind of like trigger throws the sphere that is growing, and just by the distance it turns on various objects.
Want to make a little point just to add to the wow factor in the chat, and is that in case it's not clear, all the lighting is ray traced, and every single light there is casting ray trace soft shadows as well. So there are no tip tricks, no approximations. All the shadows from all the lights are fully dynamic in real time as the lights move, and it's all with like photorealistic shadows and the penumbras and everything, which is, for anyone familiar in graphics, it traditionally has been a really challenging problem to solve with shadowing techniques.
Yeah, exactly.
Hundreds of lights would impress me. So the fact that you're into thousands is amazing.
Something that I would like to also highlight, because my favorite topic, lights also light up fog volume. So they not only lighting solid rocks, which is G-buffer thing, they also affect your atmosphere.
And another one, doubling down on the wow factor, we also have ray trace volumetric lighting.
It's more obvious in other content than this, but yeah, we do.
Yep.
There's a really nice mushroom that's or like a bit of foliage that's like a cage, and the shadows that it will throw around the place is, in previous projects, it's the exact kind of thing that you'd have to have careful words with people about controlling view lines, and that can have to be a hero asset. You can just fill scenes with complicated shadows dropping things that we would not be able to do before.
Yeah, exactly. I'm just trying to find here maybe, or here. Yeah, here I think we've implemented a kind of like collectible thing that we call Research Bee, and when activated, it just starts flying from one object to another, like activating it. And this is exactly the example that Daniel was talking about. So basically, we can run this kind of like shadows being thrown through this complex objects and creating this nice effect of the holes of light being cast from it. And the other thing I'd like to show is that for example, here we have an option to control the laser beam, which has the light on its end attached. And you can see that it can basically like affect a huge part of the level with a lot of assets in it. So the great thing is that we don't have to deal that much with the attenuation size, because it basically doesn't matter. So that's why we can use this kind of like expensive lights, not only regarding the light type, but also regarding the size of or the area that is affected by the light. So yeah, I'm just showing like we can basically just turn this whole factory on, and there are a lot of lights attached to those rings, and they are all rectangle lights that this one that are attached to those cylinders, and it all just affects the big chunk of the environment. Yeah, another example I've prepared is the showcase of the ray tracing or ray traced lights. So this is, I think, the nice example of the ray traced shadows. So we have a light source here. We have a shadow caster, and you can observe like this kind of very crisp and sharp shadow here in this close distance to the shadow caster, and this blurred shadow that is further, which is basically not achievable without ray tracing. And also we can achieve like with this kind of like strong lights, we can achieve this nice effect of the characters' shadows, especially when it's put on the ground with the blurred shadow in the distance, like so blurred that you basically can't recognize the silhouette of the shadow. And if you go near to the surface, the shadow just gets sharper and reveals the the silhouette in much sharper and clearer way. So this is also amazing. It's basically just artists kind of amazement of this stuff, but I think it looks really cool. Yeah, and other thing is that we can basically use lighting as a gameplay feature. So let me just show one or two examples of it. So let me just load the level quickly. So we have this guy, for example, and it's basically a big crystal that has a very strong light in it, and the light, just to showcase, like it has 5,000 units attenuation. It's pretty strong. It has shadow casting on, and it has also the volumetric shadow turned on, which usually is kind of like expensive thing. And we are basically using this light to open various doors or removing obstacles. Because in this kind of like mini game, in this part of the level, you can basically just skip the dialogue, spawn a drone, and basically send the drone to the crystal, and you can see that the light is kind of traveling, or the shadow is like the shadow part is creating this kind of shape. And when you stop, you can stop the light at the right moment. And when you do it, and it affects the right kind of obstacle, you just destroy it, and it can basically it reacts to the light. And yeah, it was fun to achieve this kind of result, because it's not there is no fake behind it. It's an actual light that is strong and is shining. And what we are doing, how we are set upping this, is that so you can see like there is a proper shadow from the character and all the objects around, that we are basically like casting rays from the light and checking like if those rays are hitting an interactive object, and if they do, and the light is shining on them, they react. So this is one of the kind of like gameplay features that we are using in Neurodon. And yeah, as you can see, like we can afford this kind of like gimmicks of various lights just traveling constantly from side to side, creating this nice dynamic effect of flowing kind of not liquid but energy through those crystalline veins. And one example, one more, is that for example we have this kind of puzzle that is called follow the light. And if I send the drone, it will spawn the light that travels through the pipe, and if the light hits the interactive object that can be interacted with, you can basically interact with that and activate it. So there is a multiple of them, and you have to basically follow this kind of like light object and see where the things are in the vicinity, and then activate them. And yeah, as you can see, like it's basically all about various lights being turned on, off, or changing states. So yeah,
And just
let
that
me
simple
close this
act
one.
of each light, like one coming on after the other, really just helps emphasize how many lights we're using at that point. Because if you did it all kind of like a little quicker, a little bit more together, you would lose that effect.
Yes. That's completely right. And what can I show as well is, let me just fly through the level very quickly. Is that sometimes if the level design allows us to do it, we can basically like change the whole mood of the scene. So for example, here there's a pitch dark area that you can access, and after the interaction with this research pylon, as we call it, you can just get all those interactions, and you can basically reveal the room that was completely hidden before with a lot of kind of like dynamic moving lights around in those hidden that had been hidden in those crystals. And probably we can find a lock or a collectible here that you can pick up. So yeah, this is cool thing. It clashes a lot with the experience of being lost in the dark. So we have to be really careful with that, with those kind of examples, or this kind of features of there is a completely dark level and you have to do all those interactions to light it up, which sounds like a great idea, but like in reality, the players usually just say, "Oh, okay, I don't want to do that. Let's just go straight into dark," and they get lost and frustrated, and they will uninstall the game eventually. So there are issues with this kind of like the need of urge of showing this kind of like very drastic lighting change, and the gameplay features and the readability and the experience and fun. So yeah, there is kind of constant clash between the design and art, and yeah, we have to be really careful here. So basically, like how we solved it is that as you can like see in the parts of the levels that are basically like not lit yet, we are still keeping some kind of like lighting in important places, in important areas, so the players can navigate through the space. But we are trying to keep space for the desired lighting change that happens after the player's interactions.
And those areas that are, quote unquote, not being lit, you're still using soft fill lights, right, to keep it from having that pitch black.
Yes, exactly. So yeah, we are relying on the interactions and on those kind of research bees. But yeah, as you said, like there is still some light in the this kind of like basic state or initial state of the levels, and then we can just start lighting it up.
Is it worth mentioning a couple of the things that the best practices we've learned with them. So one of the issues we've ran into rarely, but if you animate some of the properties of the lights too quickly, switching them on and off seems to be okay, but like very, very rapid attenuation increase has caused an issue once or twice. But we've been able to fix that just by reducing it a bit. But the main one is you can get a kind of salt and pepper convergence errors if you have an area light that's halfway through a wall. So if you have one of these like rectangular lights and you accidentally place it through geometry or something like that, you can get this kind of like swimming, shadowy kind of look. So if you ever do get that while working on your own project, and you've also got hundreds or thousands of lights, you need to look out for one nearby that is potentially stuck through a wall. Or if you have lights inside character, like there's a thing that we need to fix at the moment where there's a light inside the character when they climb up walls, and we just need to make sure that light gets removed outside of the character.
Yeah. One last thing I forgot to show is it's not that tied to the MegaLights, but more about the fun with flights. That we built a real projector that we can use for our puzzles. So just a quick I think last showcase, because I think we are kind of like starting to run out of time. So basically we've built a projector that is casting videos, and we can, and the basically goal of the puzzle is that we can switch through the various videos, and we can align them with the grid of buttons, and the videos are basically like showing the right sequence of buttons that needs to be triggered, and it's kind of like the real light, and the projector is real. So if you step in front of it, you will cast shadow, and it's kind of amazing that we are not dependent on any decals or stuff like that, but that's basically just a real light, which is really cool.
This is one of those examples where, like, for folks who aren't as well versed on the tech side, well, they'll be like, "Oh, that's cool," but if you actually know what's going on, you're like, a much greater appreciation for what's actually happening here.
Yeah, exactly.
I mean,
So,
the light
Sorry,
beam
go.
that was coming out of that projector as well is we're not sticking like a big poly on the back of that to project that out either.
Yes, it's a volumetric light. We have the volumetric fog turned on, and it's all volumetric lighting. So that's a nice thing about playing a video through the light, that you also get this kind of like color or coloring process on the volumetric fog, which is really cool.
Yeah, it looks amazing. Well, we have a few questions, so if we want to wrap up the show real quick, we got about 15 minutes left. Was there anything else we wanted to demo while we have it open, or was that? I mean, I could look at this all day. Absolutely gorgeous. Awesome. Well, let's do a couple questions here. That was the wrong button. There we go. Awesome. This will be a last quick reminder for folks. If you have any questions for the team here about Neural Dawn, MegaLights on mobile, anything like that, please leave in the comments now. Question in brackets followed by your question, and we'll try to get through them. We're going to kind of rapid fire through these because I know we are running low on time, but we did have a couple here. One of them was, this looks nice for dynamic cinematics, but if you play around and move the camera around, do you get ghosting, temporal smearing, shimmering, or anything else like that?
Okay, maybe I can add some points here because this kind of relates to our scalar denoiser. Yeah, so the frame complexity is super advanced these days, I would say. In our case, so one of the advantages of neural techniques is that you have ML, which is kind of cheating, because anyone that has implemented any kind of temporal technique in the past knows about, the color rectification and all the problems when it comes to reprojecting the signal to historic information and the many edge cases that you have to face in terms of these occlusions or things that like translucent particles that do not provide depth or motion vectors. In our case, and thanks to the fact that we're using this fancy neural upscaler denoiser, the model, the machine learning model can actually generalize all these corner cases in a much better way than any kind of shader-based technique could. So going back to the ghosting and visual artifacts and this question, there are still some minor artifacts that we keep iterating on a daily basis with, and we keep polishing things at runtime. But what we've seen is that NSSD is outperforming everything else out there at the moment. And when you are running on the device or desktop with this technique, we are not getting any kind of ghosting or weird artifacts. I mean, obviously with the the caveats, because probably Danny and Lucas are smiling right now because, as I said, we keep polishing things, but when it comes to particles and all these super corner cases, generally the neural technique does a much better job than any kind of shader alternative.
We're getting quite a few questions that are all kind of falling into the camp of hardware. So I'm going to kind of combine a bunch of these that we're getting here. But what is a realistic hardware that can? I'll split this into two things. What is the realistic hardware that can run this in the sense of it actually runs? And what is like good hardware or goal hardware? Like where's kind of the floor you'd recommend for something like this?
One wants to jump to this one?
Please go for it, Sergio. Or Alex.
Yeah.
That's a tricky question because we don't want to finger point on any specific device. Let's say devices that we've been developing most of the games on being released, and guys, correct me if I'm misremembering, in 2024 or even earlier. It's playable. It's not excellent experience on this device, but it's definitely playable. In devices that we shipped, or rather in chip that we shipped in 2025, that's significantly better. We got more registers. That means more complex shader code can be run without trouble. That's very important for MegaLights. We got improvements to ray tracing unit, 2025 devices, or rather hardware from 2025, to be clear, because it's not the same thing, devices from 2025 and hardware from 2025. They should be good, but they will lack on neural unit. If I recall correctly, it's not there yet. And moving on, you will have all the things. You will have enough shader core power, you will have enough ray tracing power, and you will have neural.
Yeah, so it pretty much depends on, in terms of running, you can run MegaLights on any device phone with ray tracing capabilities. In our case, we are leveraging the neural unit coming in these devices later in the year, and we're using these use cases for upsampling, denoising, and frame generation to give us a bit of a competitive advantage. Because without this, you can still run it, and you can run it as you are seeing right now on screen. You can still run it, but you will be a bit more limited because you will have to run with an upsampling solution that might or might not. And I'll have to make a disclaimer here, of course, because the existing techniques in Unreal are pretty good, of course, but yeah, you will be basically limited to what the engine is giving you for this. And as I said, MegaLights was designed for 1080p to 4K workflows. The ad hoc denoiser or the MegaLights denoiser is not as good when you go to the kind of 540p to 1080p workflows that we are working with on mobile at the moment.
I just want to shout out how impressive it was to have the phone facing away and looking and mirrored and trying to navigate there. Way better than I could have done.
Sorry about.
I just want to. I want to mention that the phone that Lucas shown. I just Googled really quickly and behind the scenes. It was released in November 2024.
Yeah, so we are basically getting a decent frame rate. As we discussed, like the problem about it that is the thermal throttling and basically the battery consumption. So those are the biggest issues that I think the NSSD and NFRU will solve.
Another question we had here, and I think this one's interesting because, well, for a few different reasons. Is adding lights or does adding lights matter from the early project, or is it something that you can focus on later in development? Multiple pronged, I think, for this one.
I think it really depends on the game. Because usually if you are creating a immersive game that relies on visuals, then some kind of like first pass of lighting is great, even when you have just level built from blocks, because you can set the mode, you can set the basic points of interest, and you can use lighting and see how it works, how it's make the scene readable, and then you basically just iterate on other passes of the level design and lighting. So yeah, but if we are creating something like completely different, I don't know, a strategy game where you just put one directional light to the scene. And the game is more kind of like gameplay focused, then I don't see a problem just playing with the light afterwards. So it really depends on the on the target basically that the game should be focusing on.
Yeah, like just to echo that, a game like this where light is the key, right? Like light is part of the gameplay and everything like that, then yeah, that's definitely something you want to kind of nail down early. I will selfishly say that you should dedicate as much resources to lighting as early as possible as you can budget, because lighting affects everything. It affects the perceived scale of an area. It affects how a player navigates in an area. It affects the atmosphere, the feeling, the mood of the play space and stuff like that. It does a lot more lifting than I think some folks give it credit for. So the more you can hone that in early, the more you can ensure that it's going to achieve the goal and that your game is going to feel the way and play the way that you want it to early on, so you don't have to start making changes later when you start lighting and going, oh, actually now this level doesn't feel right, or the play space doesn't play the same, or things like that. So yeah. Another question we had here is, does adding MegaLights increase the space my game takes up on the hard drive?
It depends what you're comparing it against. So, unfortunately, you got 3 programmers on this call, so we might get very pedantic about it. But technically, with all the extra lights you have, there is a tiny little bit of memory to store those lights somewhere. But if you're comparing it against baked lights, this is highly likely to be far less memory.
That was, yeah, that's exactly the point that I was going to do.
Yeah,
Yeah,
exactly. At the end of
when
the day,
you save those light maps as textures, textures are usually the most heavy thing in terms of storage space. Usually, audio can be, depending on compression. There's other things like that too, but baked light maps can be very heavy. So there might be, like you said, an increase in the size based off of using that, but you're very likely to reduce in other areas that would more than well make up for it.
Definitely. There's all kinds of ancillary problems with light maps as well, of how they break a lot of instancing and various things. And the development pain of having to, so when you're making like bigger AA, AAA games, having to change lighting, wait for a big bank of machines to make your lighting overnight, and then come in next day to evaluate your work that took you 30 seconds the day before, is not what a lot of artists would probably call fun. Whereas is literally,
yeah, absolutely. Like that's why, and I haven't mentioned that, but yeah, with the size of the team we haven't used any of the bought assets except one pack of crates, actually, sci-fi crates. But all the assets in the game are custom made. So we basically could spend this time, which we basically would use for this kind of like baking light map setups and waiting for the bakes. We could use this time for basically like creating the game from scratch. So that's just a side note to the project.
And it's also something to consider too, right? Like maybe it does have an effect a little bit on the size. So in this case, we'll compare using like fully dynamic lighting without MegaLights versus with. Again, there might be an increase in cost there a little bit on the storage size, but you're also increasing what you can do with your scene. So that cost, it would likely be worth it, right? It might be like, yeah, it's a little bit larger, but it gives me X, Y, Z, with it. We're about at time here, so I'm going to wrap up with just a couple quick ones here. Just to confirm, iOS devices run on ARM architecture, correct? Does ARM's neural graphics tech apply to them, or is it limited to ARM GPU Android devices?
so CPU does. CPU is, yeah, ours. Well, it's theirs. They just license the architecture. Then in terms of the neural graphics, no, iOS devices have their own GPU, pretty good GPU. So yeah, it will be mostly Android devices coming later this year. They will bundle Mali GPU with all the fancy neural unit and all the cool stuff.
Awesome. Awesome.
If this question was about can I ship game for both Android and iPhone, from what I know, Metal on iPhone has support for neural rendering stuff in several different flavors of this. So there is a room to run comparable tech, not the exactly same one, but comparable.
Awesome. Awesome. Well, thank you all for coming on and showing this off. I think that this is so cool. I'm still like, I'm familiar with the tech. I use it all the time, but it still blows my mind to see like this many lights running just in general, right? Like I'm not even beyond that part where it's like even on a high-end PC, I'm still like, wow, that's amazing. But then to see it on mobile architecture is incredible. So this is a really cool thing. I'm looking forward to what comes next, right? If we're here now, what's next for mobile. So huge shout out to you folks for joining us, and a huge shout out to everyone for tuning in as well. The show would not be what it is without you, your questions, and your time. And if any of you came partway through the stream and wanted to rewatch a section, no worries. We post all of our streams in video format that can be viewed on demand on both our both our Twitch and YouTube channels at Unreal Engine. You can also keep up with the latest news, shoutouts, and other cool information on all of our socials at Unreal Engine. And if you haven't already, come join us at the Epic Developer Community, the EDC, where we have our documentation, tutorials from both the community and Epic staff alike, forums, and much more. But again, thank you folks for joining us, and we will see you folks on the next Inside Unreal.
Thank you so much for inviting us. Thank you.
Thank
Bye.
you.
Everyone.
Bye.